Okay, gentlemen, if you have any question from the previous class, please go ahead. Okay, gentlemen, this is the summary of the continuous random variable we have discussed so far. We said that a continuous random variable is said to have following a probability density function f of x if this f of x possesses these two properties, that it is a non-negative function and the integral of this function over the whole domain of x from minus infinity to plus infinity is 1. Now here I don't mean minus infinity by minus infinity. It's a kind of notation for the lowest possible value of x. And plus infinity, this is a sort of notation for the highest possible value of x. And we saw in different questions, these two values are different. Like sometimes the question is from 0 to 1, sometimes it's 1 to 10, sometimes it's 0 to infinity, and so on. So there are different lower limits and different upper limits for different variables in different questions. Now, once you have the PDF from the question, there are different uses of PDF. Number one, you can use the PDF to find the probability. And yesterday we used PDF to find several probabilities. Number two, you can use the PDF to find the mean of the variable. Now, this second use is specifically about mean. As we said yesterday, that small f of x and capital F of x can be used for many purposes. Now, for the first purpose, you can use small f of x and capital F of x both. I'm going to highlight this one. For number one, you can use both. As you can see, I have written number 4 in capital F of x also. For number 2, you cannot use capital F of x. If there is a question that says find the mean of x, you need the PDF. If I give you capital F of x, that is the CDF, and I ask you to find the mean, you need to convert the CDF into PDF first by differentiating it. And then find the mean. Similarly, you cannot find variance from CDF. And number 4 property is the CDF itself. You can find it from the PDF. Once you have the CDF, now CDF can be used for several purposes also. Number one, it can be used for less than probability, obviously, for greater than probability, and for in between probability. Now there is one use of CDF that makes it unique, and this use is for finding a specific population percentile. Now PDF cannot be used to find the percentile. If you need the percentile, you always need a CDF. So these two functions, one of the functions I called PDF and one of the functions I called CDF, cumulative distribution function. There are some uses of these two functions that, which mean that they can be used alternatively. Like to find the probability, any probability, whether less than probability or greater than probability or in between probability, both of them can be used. But there are some uses for which both of them cannot be used. The common examples are mean and variance. For mean and variance, CDF cannot be used. You have to use the PDF. And for percentile, PDF cannot be used. You have to use the CDF. Let us try and solve a question. I have already copied a question from your book. And today we'll try to practice regarding the percentiles. Okay, this question says that a test instrument needs to be calibrated periodically to prevent measurement errors. After some time of use without calibration, it is known that the probability density function, PDF, probability density function of the measurement error f of x is 1 minus 0.5 times x. For x between 0 and 2. So the lower limit of x is 0 and the upper limit of x is 2 millimeters. If the measurement error within 0.5 millimeters is acceptable, that means less than 0.5 millimeters. If that is acceptable, what is the probability that the error is not acceptable? So the probability of X more than 0.5 is required here. This can directly be found using PDF. You don't need CDF, but if you want the CDF approach, this is how you will proceed. You have small f of X. That is 1 minus half of X, where X is between 0 and 2. The definition of capital F of B is minus infinity to a specific value b f of x dx. Now for your question, minus infinity is 0. The lowest possible value of x is 0 all the way up to b. And then you will integrate f of x, which is 1 minus half of x dx. The integration of this one will be x minus half of x square over 2 from 0 to b. Now when you put b in this function, it will be b square. This is capital F of b. B square minus 0.25 times, not b square, it's b. B minus 0.25 times b square. And when you put 0, everything will be 0. Now this is your distribution function. This is your CDF. This is your CDF in terms of b. You can replace b by x. So it will become CDF in terms of x. Or you can write it as f of x equals x minus 0.25 times x square. So this is your CDF. Once you have the CDF, let's look at question number 1 now. If the measurement error within 0.5 millimeters is acceptable, what is the probability that the error is not acceptable before calibration? So not acceptable means that the error is more than 0.5. So the required probability is x more than 0.5. This is 1 minus capital F of 0.5. Greater than probability, that is 1 minus capital F of 0.5. So that will be 1 minus capital F of 0.5, that will be 0.5 minus 0.25 times 0.5 square. Just plug in the values. And this will be equal to 1 minus, let me calculate this thing. 0.5 square is 0.25 times 0.5 square. This is 0.0625 and 0.5 minus this 0.0625 is 0.4375. 1 minus 0.4375 and 1 minus 0.4375 is 0.5625. This is the probability of x being greater than 0.5 using CDF. Now let's go back and look at the question part B. What is the value of measurement error exceeded with probability 0.2 before calibration? Who can tell me what is required in part B? This is a very complicated question. Anyone who can guess what is required in part B? Okay, since nobody can guess what is part B, let me see how much do you know from your lab part. What is the general definition of P25, 25th percentile? Can anyone tell me what is the meaning of 25th no, not 25th, let me say 30th. 25th becomes a quartile, so let me make it general. 30th percentile. How do you interpret a 30th percentile? What is the meaning of 30th percentile? What is a 30th percentile?
That your value is above or equal to the lower 30%.
I just wrote what you said. Is this correct? Is this what you mean?
Yes.
Anyone else?
I think it is equal.
Above or equal? You think it's equal?
Yes, not above.
Okay, anyone else?
The value that above all the 30% for all the value we have, the values we have.
The value, this is above 30% of all the values we have. Okay. Anyone else? Let me go in terms of the probability density function diagrammatically. Let us say this is the probability density function f of x. Starting from this point all the way up to this point, so the area under the curve is 1. So on the x-axis you have x, on the y-axis you have small f of x. Now, my question is, what is P30? P30 is a value of x. The first thing is it's a value of x. It will be somewhere here. It is a value of x such that if you measure the area under the curve below this value, area under the curve below this value is how much? It's 30%. P30 is a value of x such that 30% of the values are below this one. Someone said it, I think Faris said it. P30 is 30th percentile. It's a value of x such that probability of x less than or equal to P30, this is 30%. P30 is a value such that the distribution function at P30 is 0.3. I just came directly from this equation. Less than probability can be written as capital F. So a 30th percentile is a value of x. Listen carefully. The 30th percentile is a value of x. It's a value of x. It's not the probability. It's a value of x such that 30% of the density is below this value. 30% of the values of x are below this value. So if 30% are below, the remaining 70% will be above. So whenever there is a question of percentile, any percentile, 30th or 35th or 71 or whatever percentile, you need to solve this equation. You need capital F of x to get to any percentile. And by percentile, I mean the quartiles, I mean the median. Let us practice finding some of the percentiles. Before I practice, I want you to again see this question, because for any question of percentile, it's not tough to find the percentile. It's tough to know from the question which percentile is required. Read part B and let me know which percentile is required here. What is the value of measurement error? That means what is the value of x above which, sorry, What is the value of X that is exceeded with the probability 0.2? So there is a value for which the above probability exceeding probability is 0.2. So the upper tail area is 0.2. Which value is this?
Percentile 80.
80th percentile or 20th percentile? That's the confusion. Let me show you through the diagram. There is a value of X somewhere here, and they are saying that the above probability is 20%, exceeding probability. The probability that calibration error will exceed this value, this is 20%. What is this value of X? This is required in the question. What is this required thing? Is it 20th percentile or 80th percentile?
80.
This is 80th percentile. So this question is asking for P80. That's the most difficult part of a question that belongs to percentile, to know from the question which percentile is required. Once you know which percentile is required, then it's not a big deal to solve it. Now that you know that 80th percentile is required, now you just need to solve this equation. Now you just need to solve this equation. Capital F of P80 is 0.8, and you will get the percentile. Very simple. So let us try and solve this equation. Where is capital F of X? Where is my distribution function? Here is my distribution function. I will simply copy it and paste it there, and then I'll show you. This is my distribution function. I copy it, paste it here. Capital F of X. Plug P80 instead of X. So take this equation. Take this equation and fill the left side with the F of P80. So it should be P80 minus 0.25 times P80 square. This is equal to 0.8. Muhammad Shafiq.
It's like less than or equal, right?
Yes, it's less than or equal. In general, it is less than or equal. Did I write less than or equal? Yes. Now let's solve this equation. This is a quadratic equation. So it will be, let's take everything to the right side. It will be 0.25 times P80 square minus P80 plus 0.8. This is equal to 0. Now this is a quadratic equation. So P80 is 1 plus minus square root of minus 1 square minus 4 times 0.25 times 0.8 divided by 2 times 0.25. Did I apply the formula right? Minus b plus minus b square minus 4ac whole square root. Is it right?
Yes.
So we will get the two values. That is 1 plus minus, let me find what is inside the square root. 1 minus 4 times 0.25 times 0.8 is what? It's 0.2. Square root of 0.2 whole divided by 2 times 0.25 is 0.5. So this is going to be 2 values. So P80 is equal to either 1 minus square root of 0.2 over 0.5, or it is equal to 1 plus 0.2 square root over 0.5. So this is going to be 1 minus the root of 0.2 divided by 0.5. This is 1.1056. And this is or this comes to be 2.8944. Now the 80th percentile cannot be 2 values. It will be a single value. Now, which is the 80th percentile and which one is not the 80th percentile? One of them is 80th percentile and one of them is not the 80th percentile. Amjad Ammar.
The left one, because the right one exceeds the values that we have.
If you go back to the definition of percentile, percentile is a value of X. And if you go back to this specific question, if you look at the domain of X, the values of X are all between 0 and 2. So the percentile should be one of these values between 0 and 2, because percentile is also a value. Now, if you look at the second one, that exceeds the upper limit. So this is not going to be your percentile. You will reject this one. So the final answer is that 1.1056 is the value of X. This is the value of measurement error, such that this is exceeded by a probability 0.2. Any question from this 4.13? Let me find one more question for which I want you to practice the split domain. And then we can move on to the next topic. Let me see if I find a question of split domain. There it is. So here I found a question where I have split domain. The question says that the distribution of X is approximated with a triangular probability density function. Now the density function, there are two different density functions in two different domains. Your f of X is minus 0.025x plus 0.0875 when X is between 50 and 70. No, I think I missed the first one. Yeah. X is between 50 and 70. This is the second part. Let me pull it down. And when X is between 30 and 50, it is 0.025 minus 0.0375. And outside there is no density. So less than 30, the density is 0. And above 70, the density is also 0. Sometimes you get a question like this, where the domain is kind of split.
Not one, X greater 70.
This is a small f of X. capital F of X will be 1.
Yes, okay.
This is the density, not the probability. Keep in mind, density is not the probability. And secondly, density can be more than 1. If you see small f of x, the value of small f of x more than 1, don't worry, it can be more than 1. But the value of capital F of x cannot be more than 1. Capital F of x is the probability. Now the question says determine the probability, part A. I'm reading part A. Determine the probability of x less than 40. How do we find this probability x less than 40? This is basically integration from 30 to 40. Which function will I use? Muhammad Faris.
First one.
The first one. I think I missed x somewhere in the first function. There is x here. 0.25x dx. This is how you will solve the first one. I'll show you how to solve it with capital F of x also. Find the probability x between 40 and 60. How will you solve this question? Raise your hands if you know it. Amjad Ammar.
The probability from 40 to 50 for the first equation, and from
40 to
50 to
50,
60.
we have first equation 0.025x minus 0.0375 dx plus
50 to 60, second equation.
50 to 60, second equation, minus 0.025x plus 0.0875 dx. This is how you will find the probability for split domain. Then, although it's not asking, but what if it asks for the mean? How will you find the mean? For such a question where there is split domain, you'll find the mean like this. This will be integral 30 to 50 x multiplied by this f of x dx, whatever is in this domain, plus 50 to 70 x multiplied by the PDF in the other domain, and the overall solution will be your mean. In the first bracket, the PDF of first domain, this one will come. And in the second bracket, the second PDF will come. And the overall answer of this thing will be your mean. And same is true for the variance. If you're interested in variance, that will be sigma x square. That should be this whole thing. With x square. This is expected value of x square minus mu square. That should be your variance when there is split domain. Now this is not the tough thing. It's okay to have mean and variance from the split domain. The tough thing is the percentile. Look at part C of this question. The value x that is exceeded with probability 0.99. Which percentile is this? The above probability exceeded probability is 0.99. Is this the first percentile or the 99th percentile?
First.
It's the first percentile. It's P01 that is required. Now to get the percentile when there is split domain, you need obviously capital F of x. And to get capital F of x, you need to differentiate both of these functions. You need to integrate both of these functions. So let me copy this small f of x, and from this small f of x, I'll integrate both of them and I'll get capital F of x. That will also be split. So your capital F of x because there is no density below 30, so it will be 0. Between 30 and 50, it will be 0.025 x square over 2 minus 0.0375 times x. No, I'll have to integrate manually. Let me do it. Between 30 and 50, your capital F of x will be from 30 all the way up to b. 0.025 x minus 0.0375 dx. This should be the solution. Solve it. It is 0.025 x square over 2 minus 0.0375 x, and then you put between 30 and b. So when you put b, this will be 0.025 b square over 2 minus 0.0375 b minus, then you put 30 square times this whole thing. Can anyone tell me by putting 30 in this function? 0.025 times 30 square over 2. This is 11.2. Yes.
10.
Exactly.
No, 10.125.
Let me verify. Minus 0.0375 times 30. 10.125. Yes, this is your CDF for x between 30 and 50. 0.025 x square over 2 minus 0.0375 times x minus 10.125. And there will be another function between 50 and 70. And above 70, it will be 1. Now, I'm not going into the detail of this second part, 50 to 70. You'll have to integrate the second function like you did for the first one. Why I'm not interested? Because the question is asking for the first percentile, and I think the first percentile will be in the first part. It will be around 31, 32. It should be around the lower limit. So what you will do is, and after this question, I expect a very conceptual question from someone. When you do it, you put this capital F of, let's say, P1 equal to 0.01. So what you do is, you do 0.025 P01 square over 2 minus 0.0375 P01 minus 10.125. You put it equal to 0.01. You solve this equation, you will get the percentile somehow using the formula of quadratic equation. Now, my question is, How do you know that the first percentile lies in this part, not in the second part? Because the first percentile is a very low value, below which there is only 1% area, and you think it's close to 30. Is this the reason? This is a question for you to think. How do you know that first percentile belongs to the first part of domain? What if I ask you to find 30th percentile? How will you know where does this belong? How do you know which capital F of X to solve?
Plug in some values to check.
Let me go with an easier function. This is a tough function. Let me say F of X, it's 0 when X is less than 0. When X is between 0 and 1, it is half. When X is between 1 and 2, it is, let me identify what it will be. It's also half. And above 2, there is no density. Now, if this is your PDF, the density below 1 is half, the density above 1 is also half. Let us first find the capital F of X. Below 0, it will be 0, obviously. Above 2, the cumulative probability will be 1. Let's find it for between 0 and 1. Capital F of X will be integration of 0.5 from 0 all the way up to X. So it will be 0.5 X. 0.5 X. And when X is between 1 and 2, capital F of X will be integral from 1 to X, 0.5. And that will be 0.5x minus 0.5. So that will be 0.5x minus 0.5. 1 to 2. Now this is your CDF. Now if I ask you from this CDF, I give you this CDF in the question, and I ask you to give me 45th percentile. Which CDF will you solve? The first one or the second one? And by the first one, I mean this one, and by second one, I mean this one. The remaining two are useless. If I ask you to give me 30th percentile, how do you identify which capital F of X to solve? Ali Abdul Rauf.
I think I can substitute in both of them, and the one give me a negative value. I can exclude it.
Let's try that. Let me find 45th percentile, and I will plug in the value in both of them. And according to the first one, if I assume that the 45th percentile is between 0 and 1, I'm assuming it that the 45th percentile is between 0 and 1. If it is between 0 and 1, then 0.5 times P45, 0.5 times P45, that should be 0.45. Solving that equation for the percentile, and P45 should be what? P45 should be 0.45 times, no, not times, divided by half. And this is 0.9. And if I assume that my percentile is in the second green domain between 1 and 2, in that case, my 45th percentile will be 0.5 times P45 minus 0.5. This is equal to 0.45. And if I solve this equation, my P45 will be what? 0.45 plus 0.5, which is 0.95 divided by 0.5. So 0.95 multiplied by 2, which will be what?
1.90.
1.90. Now, which one is true and which one is not true? You got two values of percentile, blue and green. From the blue, you got this. From the blue domain, you got 0.9. From the green, you got 1.9. How do you get to know which one is your percentile?
The first one makes more sense.
The first one makes more sense, but why? It does make more sense. It is the 45th percentile is 0.9, but how?
May I answer?
Yes. How can you know that which domain 45th percentile belongs to?
I think if the percentile above 1, it is belong for this domain, and if it is above 1, will not belong to this domain.
1.9 is above 1 and
Yes.
0.9 is below 1. You got
Yeah.
1 above 1 and you got 1 below 1.
Yes, the one that is below 1, it is this domain for percentile.
Where do you get this rule from?
I just guess it.
No, we are looking for the rule. Guessing is done. The guessing is right. The first one is the right answer, I'm telling you. But how? What is the general rule? How do you get to know that a specific percentile belongs to which part of the domain?
From the PDF,
From the PDF, how?
because it says half from 0 to 1. So should we expect that?
What if it was half x, a different function? Half is like a constant line. This is a very easy function I deliberately give you. What if it was 0.5x? Not a straight function, not a simple function. Now here I gave you a simple question where the density before 1 and after 1 they are equal, 0.5, 0.5, both of them. So it makes sense what you are saying. But what if it's not equal? Below 1 there is less density and above 1 there is more density. Where is the density getting split? Look at the domain. The domain of variable is from 0 to 2. Agreed?
Yes.
Yes.
Now between 0 and 2, where is the split point?
1.
1. So what you do is you try to find capital F of 1. The density below 1, the probability below 1. Try to find capital F of 1. You plug in 1 in any of these functions, you will get the same value. Whether you put in the blue one or you put in the... Are you getting the same value? You should get the same value. If not same value, capital F is wrong.
No same value. The first one is
I
0.
think there's something wrong with the capital F of X. What is wrong? Try to find where did I make a mistake in the integration.
Nothing's wrong with the integration.
No, there is something wrong. It cannot happen that you put one in this one and you put one in this one and you get different answers. This is a continuous domain. You should get the same thing. I'll figure it out later. I'll get a ready-made CDF from your book somewhere if I find it, and I'll explain it to you how to know that from the split domain, a specific percentile belongs to which part of the domain. I'll pick this one. I have it from the book. And later I will identify where is something wrong with this CDF. This is the CDF I picked from the book. It's from 0 to 9, but there is a split point at 4. Now, if you put 4 in the first one or the second one, you will get the same CDF. Now, what if I ask you to give me the, for example, P45 here? P45 here. Now, which CDF will you use, between 0 to 4 or between 4 to 9? The answer is you try to find the capital F at 4. Capital F at value 4. That will be 0.2 times 4. That is 0.8, right? So
Yes.
the probability of X less than 4 is 80%. 4 is your 80th percentile. 4 is your 80th percentile. Indirectly, I'm saying probability X less than 4 is 0.8. This is what I just found. The split point 4. 4 is basically your 80th percentile. It's not in the middle. Now, where will be 45th percentile? Below 4 or above 4?
Below 4.
Below 4, of course. So you will use the first one. Even if the question was 70th percentile, you will use the first one. But if the question says 90th percentile, you will use the second one. Did you get the point?
Yes.
Whenever there is a question of split domain and the question asks for a specific percentile, the first thing you do is you try to see that what is the split point. The split point in this question is 4. Then you try to see which percentile is this 4. So you try to find the probability less than equal to 4. Whatever is the probability less than equal to 4, 4 is that percentile. So luckily this came out to be a rounded value, 0.8. So 4 is your 80th percentile. Now, if 4 is 80th percentile, if the required thing is anything above 80, like 90th percentile, it should be above 4. 70th percentile should be below 4. 20th percentile should be below 4. So accordingly, you will use the first part or the second part.
Doctor, what if he asked about 80 percentile?
80th percentile is 4. It is 4.
Yeah.
And this is a valid probability CDF. You put 4 in this first one or you put 4 in second one, you will get 0.8 from both of them. It doesn't matter which one do you put in. There is something wrong in our CDF that we used in the previous question. I will figure it out what is wrong. In this one, whether you put 4 in here or you put 4 in here, you get 0.8. It doesn't matter which one you are using. Try to recall the value of the concept of continuity from Math 101. We're talking about continuous functions, so there should not be a discontinuity. At 0.4, you put it in the first one or second one, you should get the same thing. The functions should join. I don't want to go into the complicated discussion, but this is how you deal the split domain. And this was all about continuous random variable, whether you have a single domain or a split domain. This is where I will stop now. And in the next class, I will go specific with some special distributions from continuous case. all the questions you expect from general case, I think I discussed all of them. I discussed how to get the mean variance for a single domain, for the split domain. I discussed the probabilities, how to find the probabilities for single domain and for the split domain. I discussed how to find the percentiles, and by percentile I also mean the median. If I ask you to find median in a question, median is the 50th percentile. So we discussed the percentile, how to find percentiles in single domain and also in split domain. So these are 6 things I expect you to know. I repeat the 6 things. Number 1, how to get the probabilities from PDF. If I give you the PDF, how to get the probabilities, you need to integrate. How to get the probabilities from CDF. If I give you the CDF, how to get the probabilities, you don't need to integrate, you need to plug in the values. How to get the mean and variance, you need PDF. How to get the percentiles, you need CDF. So overall summary is here. We can ask you 3 types of questions. We can either ask you for the probability, whether it's less than, greater than, or in between. You can use both PDF and CDF. We can ask you for mean and variance. This can be only found from PDF. And we can ask you for percentile. This can only be found from CDF. This is the end of today's lecture. If you have any question from today's lecture, you can ask me now. If you don't have a question, you can leave the session at this point.